This is the second and the last part of the previously discussed concept of immunity. Cells involved in acquired immunity. B cells. They develop in the bone marrow. These cells are activated on their encounter with foreign agents. These foreign particles act as foreign markers. The B cells immediately differentiate into plasma cells, which produce antibodies specific to that foreign particle or so-called antigen. These antibodies attach to the surface of the antigen or foreign agent. These antibodies detect any antigen in the body and destroy it. The immunity dependent on B cells is called humoral immunity. T cells. They originate in the bone marrow and develop in the thymus. T cells differentiate into helper cells, cytotoxic cells, and regulatory cells. These cells are released into the bloodstream. When these cells are triggered by an antigen, helper T cells release cytokines that act as messengers. These cytokines initiate the differentiation of B cells into plasma cells, which release antibodies against the antigens. Regulatory T cells regulate immune reactions. The cytotoxic T cells kill the cancer cells. What is active immunity? Active immunity involves the direct response to a foreign antigen within the body. In the case of the acquired or adaptive immune system, the body remembers the pathogens it has encountered in the past. This is a direct result of the active immune system. Active immunity occurs when we are in contact with the pathogen or its antigen. Antigens stand for antibody generator. It is with the help of antigens released by the pathogen that our body tackles the pathogen. So what our body does is, it starts producing antibodies to attack the pathogen based on its antigen. When this happens for the first time, it is called a primary response. Once a body experiences a pathogen for the first time, it keeps a few of the antibodies that attacked the pathogen just in case it attacks for the second time. This is known as natural active immunity. What is passive immunity? Passive immunity involves the immune response by the antibodies attained from outside the body. The primary response by the body to a pathogen it encounters for the first time is rather feeble. So the first encounter is always a little harsh on the body. What if we could immunize everyone without the need for them ever getting sick? Biotechnology has grown tremendously in the last decade or two, and now we are capable of manufacturing antibodies for diseases. These ready-made antibodies protect the body even if the body has not yet experienced a primary response. While active immunity may protect us from a disease for a lifetime, passive immunity is the more short-term. Passive immunity develops immediately and our body could begin its attack on the pathogen right away. What are vaccines? A vaccine is made up of the antigens of the pathogen that cause the disease. For example, the smallpox vaccine contains the antigens of the pathogen causing smallpox disease. When a person is vaccinated with the smallpox vaccine, the antibody producing cells are stimulated that produce smallpox antibodies. Thus, the body is protected against the disease occurring in future. Vaccinating pathogenic microbes into our body deliberately produces a similar response and is termed as artificially acquired immunity. Immunization is a process providing resistance to pathogenic microbes and other infectious diseases by the administration of a vaccine into the body. By immunization, it stimulates the body's immune system to protect against subsequent infection or disease. The lymphoid organs. The organs of the immune system which are involved in defending the body against invading pathogens causing infections or spread of tumors is termed as lymphoid organs. It includes bone marrow, blood vessels, lymph nodes, lymphatic vessels, thymus, spleen, and various other clusters of lymphoid tissue. Lymphoid organs are the site of origin, maturation, and proliferation of lymphocytes. They exist as primary, secondary, or tertiary, and these are based on their stage of development and maturation. These organs consist of fluid connective tissues with different types of leukocytes or white blood cells. The highest percentage of lymphocytes are present in the white blood cells or leukocytes. Primary lymphoid organs. The primary lymphoid organs produce and allow the maturation of lymphocytes. It also serves by generating lymphocytes from immature progenitor cells. Therefore, it is referred to as the central lymphoid organs. Examples of such include thymus and the bone marrow. Secondary lymphoid organs. The secondary lymphoid organs are referred to as the peripheral lymphoid organs as they are involved in promoting the sites for the interaction of lymphocytes with the antigen to become effector cells. They initiate an adaptive immune response. The secondary lymphoid organs include spleen, tonsils, lymph nodes, appendix, etc. Tertiary lymphoid organs usually contain very less number of lymphocytes. It plays an important role during the inflammation process.